Hello and welcome to the next C++ tutorial. So this time we're going to be taking a look at areas that we've kind of touched on a little bit. We've actually been using them without sort of really focusing on them much. And that is looking at something called conditionals, which allows us to have our code branch. So have our code do something based upon something else. So that's something that we're going to be looking at. We've had a little sort of bit of a look at it, but we're going to dive in a lot deeper and look at the kinds of things we can be doing with that. And something else that we'll be using that we already have actually worked with, we just haven't, again, drawn attention to it, is something called scope. So we're going to look at the conditionals first, and then once we've got that set up, we're going to look at something called scope. So let's dive on in. So I said conditionals are all about us being able to have something happen based upon something else. So let's set up a system where we're going to ask the user to enter in a number. Please enter a number, and I'll make it quite specific that it's please enter a whole number. Now to read that in, I need to create something to store it, so I first need to create a variable. So being a whole number, we need one of our integer types. So I'm going to use int, and then I'm going to call this entered number. So I always recommend, have clear variable names for things. Then to read that in, I can do standard cin, and then as opposed to this where I'm inserting into the stream, in this case I'm extracting from the stream, and I put entered number. So then maybe I want to do something with that number they've entered in. I want our code to branch. So I want it to tell the user some information about it. So for example, is that number even or odd? So okay, I can do that. And the way I branch, so the general thing you'll see for doing conditionals is something called an if statement. So what we do is we say if, and then in our parentheses, we write what's called our condition. And you can chain together multiple conditions, and we will have a look at how to do that. So the condition is something that it evaluates to either true or false. So a condition only has those two values. It's either true or it's false. That's how the if statement's going to interpret it. Now, say I want to check if it's even. That's something where what I can do is if I do entered number %2 is equal to 0. So a percent operator is what's known as the modulus operator. It gives us the remainder of after doing a division. So say I had a value of 2. If I divide that by 2, divides evenly, and there's no remainder left over. So that would give me 0. 4 would also divide evenly. So 4 divided by 2, it's an even multiple of it, so it would give me back, again, 0. If I put in 3, it would not divide evenly, there would be a remainder of 1, and so what I would get back is 1. So modulus can be really handy for things like that. Anything where you've got something that needs to wrap around. So say you have a world that's a grid-based world, and when the user goes off one edge of the world, they actually appear on the other side. Modulus is the main way that we would actually use for working with that. So it's really, really handy. So then I'm going to just output. So I'll put this in the braces. I'm going to say the number is even. And because I want there to be, put a new line there, I'll put it like that. So, okay, that's good. We can check if the number is even. So if it's not, I want to have it output something. So when we have an if statement, we can also then provide an else. So what will happen is it will come through, and if this condition here is true, it will run the code in this block, and then when it's done, it'll go down here to effectively line 22. So it then skips everything in the else. So it only runs one of these blocks. If this wasn't true, then it won't run this, and it'll instead run whatever I put in the block here, which I'm going to say the number is odd. So this should give me that output, so I can press F5 to run it. And then asks me to enter in a whole number. So let's add in 13. Good old lucky 13. And it tells me the number is odd, which is true. Let's chuck in another whole number. Good old 42. And tells me the number is even. So that's good. It's running the particular logic here. So that's great. Let's look at a couple of other tests that we could do. Now, these will be pretty arbitrary ones, but the intent is to illustrate something. So, okay, what if I had a scenario where I want to output something if the number's below 10, another thing if the number is between 10 and 20, and then another thing if it is over 20. So I've got 3 different scenarios there. So I could start with, okay, if it's less than 10, and then I could do an else, and then in the else do another if. So I could, then go and check, okay, well, if it's not less than 10, I could check if it's less than 20. So that's absolutely a viable way of doing it. But it starts to get very, what we call nested. So we're nesting statements inside others. Our code starts to move further and further across to the side. So it's taking up more screen space, which means it's potentially more likely that chunks of code will cut off and we have to scroll to be able to see all of it. And that's not great. We want to try and avoid code getting too nested wherever we can. This applies to if statements, applies to loops, anything like that. We want to try and avoid it becoming too nested because it makes it a lot harder to read. And having the code be easy to read is really important. Easy to read code is much easier to understand what's happening, and it's much easier to debug. So you're less likely to run into issues, and if you do run into them, it's going to be easier to fix them. So, okay, there's a better way that we can do this. If we're checking multiple conditions, we can actually use else if entered number is less than 20, and then we have an else. So this block runs if less than 10. This block runs if less than 20, but will not run if less than 10, because it will only run one of the blocks in this chain. That's the important thing. So if the number is less than 10, it will run this, and it skips over all of the rest of these blocks. If the number is, say, 12, it will come in, this condition doesn't get met. So then it goes to the next thing. It says, oh, okay, you've got an else if, it's attached to this. Well, the number is less than 20, so okay, I'll run this block, and then I'll skip this one. If we provide a number and it's 25, it's not going to run this, it's not going to run this, so then it falls through into the else. So this block here, when we have an if and then an else if or an else, if we have ones chained together, those are treated as one thing. They are effectively one block that is testing something in multiple ways and is doing different things based upon the results of those tests. So it's treated as one thing. And order matters because it will check the things in order. And the else needs to always be last. If I tried to move this so it is above here, it does actually give me an error, which is good, because that's something that's not valid. So, okay, in this case, we can say standard cout. The number is less than 10. Here it's actually, the number is less than 20 and greater than or equal to 10. Whereas in this final case, the number is greater than or equal to 20. So now I can check and test that this works. So let's add in 5,178, because why not? So it's even, and it is greater than or equal to 20. I can then check a couple of other numbers. Always good to make sure you check the code with a range of different numbers. So it's an important thing. When we're writing code, our job is done once we've tested it and made sure that it works. And also if we're working with other folks, that folks know how to be using any of the stuff they need to from it. So always make sure you're testing the code. One of the big things early on with writing code is don't leave a large amount of time between writing the code and testing it. One of the most risky sort of things you can do is get there and code for, coding for a few hours and you haven't hit run in that entire time, or even tried to compile it. Always try and be, testing, I would say every, 15, max 30 minutes at most, but generally keep it pretty short time frame. That lets you know any errors they've happened in the last sort of 10, 15 minutes. They're not something that's like, okay, I've written so much stuff here, it could be anything that, from the last few hours. So always be checking regularly. So, okay, we could use multiple else ifs as well. So that's good. We can see those. What if we want to test multiple things? What if I wanted to output something, okay, I want to know if the entered number is even. So, like of that. And let's say I want to also know if it was evenly divisible by 5. So, okay, well, if entered number, %5, and I want to just output something in that case. So again, we're nesting lots of if statements, which is something we can do, but doesn't help with readability of the code. What we can do is we can actually test multiple conditions here. How I do that is we have two main operators that we use for doing that testing. And we have one that's called an AND operator, which looks like so double ampersand is what's referred to as the logical AND. And we also have the double pipe, which is the logical OR. What these mean is, so it's similar to the English language meaning of these words. So if I wrote this, so I'm using the ampersand operator, how we would read this is if the number is even and the number is divisible by 5, then do this logic. So both of those conditions need to be met. So AND requires each condition on either side of it to have to evaluate to true. Or if I was using that, would mean it would run if it was divisible by 2, so if it was even, or if it was divisible by 5. So it will run more often. So an AND is a narrowing, a restricting of the case of where something will run, whereas an OR is expanding the case where something will run. And you can use multiple of these, and the ordering for these, while there is specific ordering of how things get evaluated, from a legibility point of view, I recommend always putting brackets around any conditions that you are combining with these logical operators, because that removes any ambiguity. Yes, there are very, very clear rules in the language specification that the compilers follow in terms of the order they evaluate them. There absolutely is. And there are, so those, they're generally sort of expectations we'd expect there in terms of things like multiplications and divisions will be resolved before additions and subtractions. You will have in something like of this, the modulus here would get evaluated before it does that comparison check, the equality operator there. And that would get evaluated before the ampersand does. So yes, there are those rules. And those blocks, if in doubt, it'll evaluate left to right. So that is rules that are in there. But you don't want to have the code only make sense if someone understands those rules and has a very good internalized representation of them. You want to make sure that it's very clear what is happening to someone who is relatively unfamiliar with the rules for the those evaluations. Don't have code that only makes sense or is understandable if someone has a very specific narrow niche area of understanding. That's really not a good way because it makes the code harder to maintain. So something like of this, always put brackets around it, makes it very clear what's actually happening. We can actually, and I do this where things get more complicated because there's no limit to how many conditions we could check here. And you can get ones where, in particular for very complex things, it ends up being multiple lines. So I've worked with ones where you do end up getting to the point of it being 2-3 lines. Each line is doing 2 to 3 checks. So you've got like 8 or more checks that are happening in the if statement. And that's a mess to work with. So what we can do is actually pull these out and make it a bit easier to work with. So we could do things like have bool is even, and then we set that to this, because that's what these are evaluating to, is a Boolean. So then we can put it like that. Then we could have another one, bool is divisible by 5. And we do our entered number, %5 is equal to 0. Then this becomes significantly easier to understand. I don't have, I can see very clearly up here, I'm pulling out those calculations, so I know, okay, is it even? And it's very easy to check these and make sure that the code makes sense, that it's doing the correct thing. And then this if statement ends up going from something that potentially might need a comment to make it clearer to something where the code doesn't actually need a comment in this case, because just reading the code describes completely what is actually happening. If the number is even and the number is divisible by 5, then do something. Makes it much clearer, much easier to understand what is actually happening. So that's something to always keep in mind, that with our if statements, you can absolutely pull stuff out into variables like this. And this is something where you might be concerned about, okay, I'm creating all these extra variables. Is that going to be a problem? Really? I've yet to see it cause a problem. Now, while that is not in itself conclusive, this is something where the compiler and then the linker that runs afterwards to generate our executables, those are quite sophisticated with the optimization of our code. Very, very sophisticated, honestly, with the optimization of the code. And this is something where, scenario like of this, they'll actually be able to optimize that probably to exactly what it was before. It probably won't actually generate any different in the way of code. If we really wanted to, we can actually, and we'll look at how at another point in time, we can actually see what it ends up generating for a case like of this to see if it is different or not. But I would expect it's probably going to generate the same code. So I would strongly recommend doing things like of this if you're testing complex conditions. It's going to make it much easier to read the code, and it's just so much clearer. So strongly recommend doing that. So we can just output our message by 5 and is even. So we can then check that. Should work. There's no reason why I wouldn't expect it to work. So let's give a number like 200. It's divisible by 5 and is even. Let's then try something that'll be divisible by 5, but not even. And we can see we don't get the message. So it's good. That's working. So we'll add in here, both must be true. Either, or let's go for one must be true to evaluate to true. I'm going to make those line up so it's neater. Cool. So, okay, we can see we can do some conditional checks with stuff like that. And we've seen with if statements, we're attaching blocks of code using these braces. And we've seen, we know braces essentially encapsulate a block of code. They mark out the beginning and the end of a block of code. We can do an if statement where we're not actually checking, we're not attaching a specific set of multiple lines to it. If we just had a single line, we could do is divisible by 5. Number is divisible by 5. So if we just want to run a single line, we can do that. We can omit the braces. Now, if we omit the braces, it's only a single line that we can attach. So the braces are necessary if you need to attach multiple lines of code. If it's just a single line, you can omit the braces and just use that single line. The main thing I would say with this is only do this when it's a relatively simple or small condition to write, and when the block of code that's being run is relatively small. You don't want to do this with something where the if statement ends up having 20 different conditions and spans multiple lines, or that what you're running here is something that needs to, it's still a single line of code, but it might be a single line of code that's so long it spans a huge area. In cases like of that, I would still use braces. Even though it's not strictly necessary, it helps with readability of the code. And as always, readability is just so important with the code. But this will work. I can just run that single line. So we'll run this just to verify that it works. So let's put in 55. So we can see we get the message. So that's good. So, okay, we've seen different ways of working with our conditions. And we have a lot of different operators, so ways of doing comparisons. We've seen ones where we can check if something is equal, which is a double equals, not a single equals. Using a single equals is always an assignment, even in an if statement condition. So don't use a single equals for testing here. From memory, I don't think it warns for that, but let's double check. I know C# does warn for it, but I don't believe C++ does, or it might. We'll find out. If it is equal to 42, so we can see it doesn't error, it does warn, so we do get a thing telling us, yeah, you probably meant to do this. Now, if I did this and bring this all the way up to the top here, and then I'm going to run it. Okay, let's add in, make it 200. And I don't see any of the other ones down there because this has actually changed the number. So it's good that it does now give you a little bit of an alert that this is probably not what you're meaning to do, but the code will still run. So it's very easy to miss. So just be mindful of that you use double equals. So the main comparisons, things like of that we use is something equal to something else. Well, let's actually put these as A. So this is saying is A equal to B. So we have that. We want to check the opposite. If we want to check not equal, then we would do exclamation mark. So exclamation mark is a not. So this, we're saying if it is not equal to B. We have seen our other ones where we've got our less than. So main other ones we've got is we've got less than. We've got less than or equal to. We've got greater than and greater than or equal to. So we've got A is less than. Facing like that. So less than or equal. These just because I want to have them neatly lined up. So in this case, greater than. And then we have greater than or equal to. So these are our main operators that we are using for comparing things. So, all right, we've seen lots of ways of comparing things. We've seen lots of stuff we're using braces. And I mentioned we were going to look at something called scope. So what scope is scope determines the visibility of something. It determines whether one thing can see something else. And braces that we've been using all this time, braces are used as part, when they group a block of code, they are marking out a scope. So they're marking out a chunk of visibility. Now the way, the general rule is you can see something in a scope that is above you. So a parent scope. You cannot see something that is a sibling scope, so a scope that's at the same level, or a child scope, so a scope that is at a lower level than you. So this code in here can see entered number because this scope is a child of our scope up here, which means the child is able to see information that the parent holds. So I would be able to output here. I could say like this. Entered number, like of that. The child has access to that information. And we'll do this for both of these. So it's able to see that because it's in a scope that is outside of it. Whereas if we wanted to create a variable in one of these blocks, so say I created a variable here. Test value is 50. And then I tried to output test value. You can see even the autocomplete is saying, I don't know what this is. And it won't work. It's undefined because it exists within this scope, which means code in here can see it. A child scope of this could see it. So I could write, some block in here of just is even, and then I could do, test value plus equals 50. I could do that because it's running within the scope that it exists in. Whereas here, it doesn't. So scope is really, really important for determining what things can be seen where. So you can always see into scopes that are above you, but you can't see into other scopes. So you can't see into ones that are below you, and you can't see into ones that are at the same level as you. You can only see stuff that's in your scope and in the parent ones. So really, really important because it makes a big difference in terms of what stuff you can see where. And it's something where that's sort of the main rule with it is that visibility. And that actually allows us to do some useful things because a scope doesn't need to be attached to an if statement. I can actually just go and create a scope. So I could just create a value thing here Okay, well, test value is 50. And I could create another scope right after it. Test value is 42. So this can be handy if you've got, because our variable names can't collide. So using a scope, you can create an isolated block of code where you use a particular variable name and you're able to work with it. And then as soon as that scope's done, then, it's no longer holding that variable name. So you can then have another scope right after it using the same thing. So if you've got similar bits of logic and you don't want to go and create lots of variables, or it's a block of logic where at some point you might want to try and refactor that to organize it a bit differently, it can be good to put stuff into a little scope like that just to more clearly delineate it so that it stands out, so that it's a bit easier to work with. That's just something to be aware of. The other thing that'll happen with scope is these two are fine at the moment. If I went and created a variable here called test value, and I made that 102, you can see this is actually fine. It's not giving me any errors. And if I go and output test value, like that, and then let's, as a final thing, output it here. But before I run it, have a think about what you think the values are that we'll see. We'd likely expect that we'd see 50 and 42 here, but what value do you think you might see on this line? So we're going to run it, and we have to enter in our number. So we get 50, 42, and 102. These variables, we can set up one here, and it's got the same name, but because it's within a different scope, it's actually fine. The code will always access the variable that is essentially closest to it. So a local variable to that scope or the most local variable to that scope will be used as the priority. So you can do stuff like of this. In the question of should you do stuff like this, the answer is very, 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 very much no. Because one of the things that we want to always avoid with code is ambiguity. Now it's clear in this case-ish what's happening because this is created very close to these. Say this function, this block of code was 100 lines long, 1,000 lines long. There could be a very, very, very large distance between where this is created and where these are created. And that could result in confusion. So this is something that it's not going to typically give you an error or a warning for, but it is something that you want to avoid. It is not good practice. It's actually highly risky because it starts to make the code ambiguous and harder to read. And it also makes the code a bit more fragile because you could very easily be confused about what the particular values might be. So we want to never do something like of that. So scope allows us to do some useful tricks, and as is kind of the nature of C++, there are things that scope allows us to do that we probably shouldn't. So stuff like of that with the variables, you can reuse names in cases like of that where it's a variable from a parent scope. You can create a variable of that same name in a child scope. Can even be, if I could actually have a thing here where I could go, well, float test value is 1.2. It can be a different type. It can be completely different that you use the same name, and that's quite risky. So we want to always avoid that. So scope is great for marking out blocks of code, can be really useful for sort of isolating, segmenting off little chunks of code like of that, but we don't want to run into issues. So although we can reuse a variable name, this is okay because they're only declared within that actual scope, but using it to essentially hide a variable that's in a parent scope is not a good practice. It's quite risky, so we do want to avoid doing things like of that. Always trying to avoid things that make the code ambiguous or confusing, or the potential for mistakes there. But that runs us through some key things there with conditionals, with scope. So dive on in and experiment with it. As always with learning a new language, one of the best ways for learning a new language is experimenting and testing out different things with the code. So look at other conditions that you might want to try and add. We've seen having 2 conditions here, but have a go with adding in so you've got 3 or 4. Start mixing and matching ones where you've got the and conditions and the or conditions. So mix and match ones, try out different combinations there, and experiment with it. That's really the best thing you can be doing for learning coding, is experiment with it and practice the bits of the code. You'll learn a lot from that process of it. Thanks folks, hope you found the video interesting and helpful. If you have, chuck in a like and subscribe, it really helps out, it's really appreciated. If you're looking for the code for the project, it is available up on GitHub, and the link to that's in the description below. As always, the code is freely available for you to use in any of your own projects, commercial or non-commercial ones. If you've got any questions, chuck in a comment below. And if you're looking for other ways to support the channel, then I do have a Patreon, and there's a link to that in the description below as well. But until next time, bye.